Welcome to the series Clippers with DC supply. In this tutorial, we will look at the third example on this particular topic. So here I have a circuit which makes use of a DC supply. So as you can clearly see, we will be making use of a transition voltage of minus 5 volt. So I need to draw this or mark this on my input signal. So I'm going to mark this here. This is minus 5. One major observation that you need to do here is that the input is a square waveform, unlike the two examples that we saw earlier where we had a sinusoidal input. Here the input is a square waveform. Moreover, if you observe, the amplitudes are not the same. The positive amplitude is plus 20 and the negative side of the amplitude is minus 10. So if you look at this circuit, a diode will be on whenever the anode potential is going to be greater than the potential of the cathode. So for this case, for the case when the diode is on, we will have the diode to be short circuited. So let us write the output equation by applying KVL to the circuit. So we have Vi plus 5 minus V out is equal to 0. This is obtained by applying KVL to the circuit. And we have considered the right hand polarity for all of them. Plus Vi plus 5 and minus V naught. Right? So let us analyze. So whenever the input is above minus 5 volt, that is the transition voltage, the diode is going to be on, and below this the diode is going to be off. So we will take different cases. Case 1, when Vi is equal to minus 5. So when Vi is equal to minus 5, this equation can be written as V out is equal to Vi plus 5. So you have V out is equal to minus 5 plus 5, that is equal to 0 volt. Case 2, when Vi is equal to 0, V out is equal to 0 plus 5, that is equal to 5 volt. Case 3, when Vi is equal to the positive peak plus 20, V out is equal to 20 plus 5, that is equal to 25 volt. So we will draw the waveform. So when Vi is equal to minus 5, we have output to be equal to 0. When Vi is 0, we have output to be equal to plus 5, and when Vi is equal to plus 20, output is going to be equal to plus 25. So this is going to be our output waveform, and this is going to repeat again. When we come down, this is going to be at 0, our output is equal to plus 5, and then at minus 5 it is going to be equal to 0. Now let us analyze when the diode is off. So when diode is off, it is going to act like an open circuit and output is going to remain equal to 0 volt. So this is what you get. Now in the example 2 that we saw, we had seen a sinusoidal waveform. So that is why we could observe that the output waveform was exceeding the limits of our zeroth line, right? It was going in the negative cycle also. Whereas since here it is a square waveform and the transitions are very sharp, that is why this looks more like a negative clipper circuit.